Alright, so this is on section 6.7, which is on small sample test for the difference between two means. So let's do an example. So because it's small sample test, we need to assume that the samples are normally distributed. And we also need to assume they're independent. Okay, so let's say for xi, the sample size is 10, the sample mean is 44.1, and the sample standard deviation is 10.09. For y, the sample size is 10, sample mean is 32.3, and the sample standard deviation is 8.56. So if you look at the sample means, the sample mean of x is greater than the sample mean of y. So we want to conclude that the population mean of x is greater than the population mean of y. So that can be translated to mu x minus mu y greater than 0. And the null hypothesis is the opposite of the alternate hypothesis, so it's mu x minus mu y less than or equal to 0. Okay, so first we have to find a null distribution. The mean is 0, so it's not hard to draw. The mean is 0. The value x bar minus y bar is here. It's 11.8. So before we calculate the tail, we need to first figure out the degree of freedom. So the degree of freedom, if you recall from chapter 5, the degree of freedom is this crazy number. Well, luckily we have all the numbers ready on above, so we can just plug all of them in. This is equal to 17.53 because we are rounding down, so it's 17. So degree of freedom is 17. Now we just need to calculate the t-value. So let's use this. So the t-value is equal to 11.8 minus 0 divided by the square root of sx squared over nx plus sy squared over ny. Again, all these numbers are ready for you on above, so we can plug into the calculator. This is equal to 2.820. Now, if we look at the degree of freedom being 17, 2.820 is between these two numbers. So that means p-value is between 0.01 and 0.005, which in particular p is less than 0.05. So we can reject h naught at the 5% level and accept h1. Alright, so let's see we can improve our results. So as you see, x bar minus y bar is 11.8. So maybe we can strengthen our alternate hypothesis a little bit. So instead of showing that mu x minus mu y greater than 0, maybe you can prove that mu x minus mu y is greater than 2. So let's do 2 here. So this is also 2. Alright, so that changes a few things. Null distribution now has mean equal to 2 instead of 0, but the degree of freedom is still 17 because because 2 does not appear in the degree of freedom, so it's still 17. X bar minus y bar is still 11.8. But now we have to change this 0 to a 2 here. So that changes our t-value. So the new t-value now it's 2.342. All right, so that's that gives us different result. So let me erase this part. So because t is equal to 2.342, let's search for row 17. Now t-value is between these two numbers. So p is between 0.025 and 0.01. So that means p is still less than 0.05. So we can still reject h naught at the 5% level and accept H1. So we can, in theory, we can keep doing this and then see if we can change this 2 to a larger and larger number and improve our result. But we're gonna stop here.